The medieval era is often characterized as a time of darkness in the history of science, particularly for the Western world. However, to the south and east of the Mediterranean, the Islamic world was experiencing a golden age. From roughly 750 to 1250 CE, the Islamic Empire achieved remarkable scientific advancements, introducing innovations that have had a lasting impact, including cataract surgery and algebra. This period also illustrates a crucial lesson: diversity fosters superior scientific progress. At the time, the Islamic Empire spanned from the Arabian Peninsula to China, and westward through North Africa and the Iberian Peninsula. Several factors contributed to this flourishing of science. In the early years of Islam, the quest for knowledge was intertwined with religious aspirations. Science and faith were seen as one. Muslim scholars undertook the monumental task of translating countless manuscripts from Greek, Roman, Persian, Indian, and Egyptian scholars into Arabic, thus amalgamating the wisdom of various civilizations. Moreover, the empire was home to a diverse population, including Persians, North Africans, Spaniards, Portuguese, Chinese, and Arabs. This rich tapestry of backgrounds facilitated the sharing, translation, and exchange of ideas across the region. One of the most notable figures of this era was the Persian scholar Muhammad ibn Musa al-Khwarizmi, often regarded as the father of algebra. He worked at Baghdad's House of Wisdom, a library that attracted scholars from various cultures who collaborated on diverse scientific endeavors. While many of his peers focused on ancient texts, astronomy, and medical advancements, al-Khwarizmi concentrated on mathematics, specifically the quadratic equation. For thousands of years, civilizations like the Egyptians, Chinese, Babylonians, and Greeks understood the relationship between the length of a side of a square and its area. However, al-Khwarizmi was the first to formulate a general method for solving quadratic equations using variables as placeholders rather than specific numbers. This revolutionary approach allowed him to discern and solve problems universally, thereby laying the groundwork for algebra as we know it today. While al-Khwarizmi advanced mathematics, three Persian brothers known as the Banu Musa significantly contributed to engineering with their work, the Book of Ingenious Devices. This book, which documented around 100 automatic devices, showcased their inventions and those inspired by earlier works, including devices from a Greek, Indian, and Iranian origins. Unlike the Greeks, who concentrated on theoretical mechanics, the Banu Musa emphasized practical applications. Although some of their creations were not exceedingly useful, they demonstrated an artistic vision in engineering, akin to collecting art. For example, they devised an early form of an automatic crankshaft for devices that could refill containers of water. This innovation foreshadowed modern crankshaft design, which serves a similar function in today's engines. In addition to the House of Wisdom in Baghdad, another academic center thrived in Bukhara, a Persian city along the Silk Road. This city nurtured great minds, including Abu Ali al-Hussein ibn Abdullah ibn Sina, a polymath who blended Eastern and Western thought. He made groundbreaking contributions to multiple fields of science, explored principles of motion preceding Newton, observed a supernova, and examined complex issues like consciousness and infinity. His most renowned work, The Canon of Medicine, outlines surprisingly modern principles for treating ailments, including cataract surgery techniques and drug testing procedures, emphasizing the importance of isolating diseases to determine drug efficacy. While Ibn Sina's insights were remarkable, they were also shaped by diverse influences. Learning arithmetic from a local grocer, he engaged with the texts of preceding scholars and incorporated knowledge from Indian, Chinese, and Greek medicine, which led to his holistic approach to healthcare. This rich history underscores the notion that the scientific achievements of this golden age stemmed from collaboration among individuals with varied social and academic backgrounds. While these scholars benefited from a unique convergence of historical knowledge, Modern research supports the idea that diversity itself enhances scientific inquiry. A 2015 study from Harvard, for instance, investigated the correlation between the ethnic diversity of research teams and the quality of their publications. Analyzing 2.5 million scientific papers from U.S. teams, the research found that teams with a mix of 4 to 5 ethnic backgrounds received 5 to 10% more citations and published in more prestigious journals than less diverse groups. While it's possible that diverse teams have broader networks, emerging studies suggest that diversity improves the quality of research, fostering creativity by reducing assumptions and encouraging rigorous arguments. Greater cross-cultural interactions, in turn, can influence the way individuals think, leading to innovative ideas. The Islamic Golden Age, characterized by its rich cultural intersections, served as an exceptional environment for such creativity. Many concepts developed during this time transformed contemporary practices and continue to inform modern research. This history reminds us of the value of collaboration among diverse minds.